Hi everybody, it's Mr. Lee. Today we're going to go over distance versus displacement. Alright, to get us started, we need to go into the definition of position. Now you might be thinking to yourself, Mr. Lee, I know what position is. But in terms of physics, there's a very specific definition of position, so let's get that down. Position is where a object is at any particular time according to a reference frame. Now there's a lot of physics terminologies there, such as reference frame, and we'll get into reference frame in a little bit. But basically, the short version of reference frame is just where you are according to something else. All right. Now, to get a little bit more specific about position, we need to go over a couple of terminology. For example, the first one that we need to go over is the usage of the term variable. Now, variables are what we use in our equations, and it's like a shortcut to tell us what is being used when we use our numbers. And so the variable for position is x. You can always remember this by pirates, right? Whenever they have a map, x marks your spot, or x marks the spot of the treasure. So x is the position, it is the location. Okay, so x is the variable. And I find that a lot of times students get variables and units confused. X is the variable, however, m, or meters, are the units. Okay, and sometimes we use kilometers or centimeters. We never use feet and we never use miles because we always use the SI unit, which are meters. Okay, so x is the variable, and we can say that m is our unit. Okay, and with units we can always add prefixes such as kilo for kilometers or centi for centimeters, and it just gives us an idea of the size of the variable. All right, next up we have distance. Now, just like position, distance might be something that you are used to using in everyday life, but of course, for physics, there's a very specific definition. All right, distance is the total length traveled between two positions. Now, you might be thinking to yourself, Mr. Lee, that I get it, right? That's something that I would use to describe distance in my everyday life. But I want to highlight a word here, because this word actually makes the biggest difference, and that word is the total. Okay, because that is the key word that separates distance from displacement. All right. Now, much like distance, the variable and the units, they're pretty much the same. However, you might see distance, the variable for distance, be the letter D. Kind of makes sense, D for distance. Okay, but I see that change from time to time. So we have that, and last up, the big one, displacement. Now, displacement. If you've seen this used in everyday life, that's pretty cool. But for those of us that don't use the word displacement in our day-to-day language, here is the physics definition. Displacement is the change in position of an object. Now, here's something cool about physics. With physics, a lot of the times the definition is the equation of the vocabulary term. All right, so I'm going to break this definition down word for word, because there's a lot of very important things here. The first one is this word change. Right, now let's get this. Yeah, change. All right. Like I said, with the definition we have a lot of equations, and so change is part of the equation for displacement. Now, in physics we use this triangle to represent change, and that triangle is what we call the Greek letter delta. Right? Delta means change. So the equation for change will always be final minus initial, no matter where you see it. If you see that triangle, delta, we are always thinking about the final minus initial. Now, when we say final minus initial, we always add a variable to it. So in this case, change in position, let's get a different color here. Let's get blue. So change in position, we would write it like this. Delta, if you remember, the variable for position is x. Okay, so that will be the change in position. And the equation would be, remember, delta is a final minus initial. So we have x, look at this is what we call a subscript. That's just kind of like an adjective or a way to describe the variable. So this is the final position. We always read right to left, final position minus the initial position. Okay, and that right there is the equation for displacement. It is the change in position of an object. Now, that is the physicsy definition of it, but if I were to give you an easy way to memorize it, I've heard it like this. It is the path that the crow flies. Now, I never truly understood it, so I'm going to change it up a little bit. Displacement is, let's say, the path that you would take if you had wings. So instead of taking the roads, making left turns, right turns, all these kinds of turns, you would just go straight to where you would need to go if you were able to sprout wings or just have the ability to levitate and fly directly to your location. Okay, it is the shortest path. Maybe I should add that. It is the shortest path that you would take if you had wings. Okay, whereas distance is something that we are used to, and it is the path that we would normally take because there are obstacles in the way. All right, now you might be thinking to yourself, Mr. Lee, I don't really see the difference between distance and displacement. Well, if that's the case, I think the best thing that we can do is take a look at a example. So I have here a scenario. All right, here we have Mr. Lee. Mr. Lee is at position 0 meters here, and I walk to the right. Okay, I walk to the right 100 meters. Okay, so nice and simple. In order to figure out my total distance, all we have to do is take a look at the amount that I traveled. So in my first trip, let's say this is trip 1, I just go from here, and I go to the 100-meter mark. Okay, I don't care if I went to the right, to the left, up and down. I just went from 0 meters to 100 meters. So in my first trip, my total distance would be 100 meters. Okay, so now let's do trip 2. Let's do it with this beautiful blue color. All right, trip 2, let's say I start at the same spot. I go all the way to 100 meters, but then I go right back to where I started. Okay, now in this case, my total distance, I went to the right 100 meters, and then I went to the left for 100 meters. Now notice here, even though I'm going to the left, I'm using the addition sign. And that's something that will come up with displacement, so keep that in mind. Because distance is the total amount that you traveled. It doesn't care about positives or negatives. So I would say that my total distance was 200 meters. Okay, kind of makes sense. And for good measure, we'll do a third trip. 3, I start here, I go all the way to the right, I go all the way to the left, and I go all the way to the right again. All right, so in this case, oh boy. So in this case, we have a distance of 100 to the right, 100 to the left, and 100 to the right for a total distance of 300 meters. Okay, and like I said before, distance is just something that we are used to. So there's a couple of things that we need to absorb in. First of all is we take the total, okay, and the total here, we just add, okay, no subtraction. And we don't care about the direction. We don't care about up, down, left, or right. However, all of that changes when we get to displacement. All right, so let's take a look at displacement. Now, I'm going to take things a little bit slower here because displacement, things do matter, okay, such as positives and with negatives when we take into concern of the equations. All right. Now, trip 1, okay, I'm going to start at 0 meters and I'm going to go to the right 100 meters. Now, we got to imagine this. If this were a coordinate plane, so what that means is, you might remember this in math class, where we have the y and the x. Okay, and we say that right there in the center, I'll make that red, right there in the center is position 0, 0. Okay, as in x is 0 and y is 0. This is position 0, 0. And so whenever I go to the right, I'm going along the x-axis. Okay, if I go up, I'm going up the y-axis. Now, nomenclature states that if we go up, it'll be positive. If we go to the right, it'll be positive. If we go to the left, it'll be negative. If we go down, it'll be negative, unless told otherwise. And that's very important because sometimes that'll change. All right, so trip 1, let's say we go to the right a total of 100 meters, right? We make this entire trip. So let's get used to using our equations. Trip 1, delta x. Remember, delta x means displacement. So my final position was 100 meters, okay, minus my initial position, which was 0 meters. So my total displacement was 100 meters. Now, if you remember from before, trip 1, I had the same displacement as my total distance, right? From 0 to 100, I traveled a total distance of 100 meters. But in this case, my displacement and my distance, it's the same. All right, well, I guess I should write up here xf minus x0, okay, as a reminder of what equation we are using. All right, so let's change things up a bit. What about trip 2, you might be asking? All right, so let's do trip 2. So for trip 2, let's say I start here, okay? And if I remember correctly, I go all the way to the right, I stop there, and I go all the way back. All right, so this is trip 2. So if I were to do the displacement, remember displacement is final minus initial position. Now you might be seeing that I'm writing out the equation, and I want this to be a good habit that you get into, because writing out the equation, and trust me when I say this, it keeps things organized and neat so that you don't get confused when you're doing the math. So my final position that I ended up at was at 0 meters, position 0 meters. And my initial position, if you remember, where did I start? I started at 0 meters. So what was my total displacement? 0 minus 0 gives us 0 meters. I got nowhere. If you start and you end at the same location, you got nowhere. All right, next up, let's do trip 3. Okay, so trip 3, I believe I started here. I go all the way to the right. I go all the way to the left. I go all the way to the right again. Okay, so let's start off with our equation. Like I said, it is a very good habit to start writing out your equations. Trust me when I say this. My final position was at 0 meters. My final position was at 100 meters. And my initial position was at 0 meters. All right. So in this case, what was my total displacement? Well, my total displacement was 100 meters, just like trip 1. Now, to give you a sense of how this is different from total distance, let's do the math in a little bit a different way. Okay. So instead of using this equation xf minus x0, let's use positives and negatives here. So if you remember, in trip 3, I went to the right 100 meters. So I'm going to write that in, 100 meters. Positive, because I'm going to the right. And then I went to the left 100 meters. Negative 100. And then I went back to the right 100 meters. Okay, so you can see here that this is a way of looking at displacement in the scope of distance, right? This is what I actually traveled. However, 100 minus 100 plus 100 still gives us the same displacement of 100 meters. So you got to think of it like this. It's as if I start here, go to the right, go to the left, and go to the right again, that middle part doesn't even matter, right? If I just started in my original position, I go to the right, and I end there, that would be the same displacement. All right, now, let's give this a little bit more context. So far, we've been only doing lefts and rights, but what if we change it up? Okay, so let's get really deep here, all right? You start off every day at your bed. Okay, you start off at your bed, and let's represent right here as your bed. I'm using the rainbow, the galaxy marker here to represent the philosophical part of physics, right? So you start off at your bed. Oh, it's, I don't know, 7 a.m. You're ready, and you wake up. Oh, okay, and you wake up, and you go to the bathroom. All right, so you go to the bathroom, and you brush your teeth, you do your thing, and then you go down to the kitchen, right? You go down to the kitchen, you get your breakfast, and you get into your car, and then you go into a car, and you go for a joyride. Where are we? We're in Delaware. Why Delaware? I don't know, because we're in Delaware. All right, and then you're like, crap, I gotta go back home for lunch, right? And so you go all the way back home for lunch, and then you eat your lunch. Actually, that's your bed, so let's go to the kitchen right there. All right, so we go to your kitchen, right? And you get a nice sandwich, and you're like, you know what? That road trip was super fun. Let's go to another road trip. Where are we going? Where are we going? I don't know. Let's go to Alaska. All right, so here we are in Alaska. Why are you in Alaska? I don't know. They have mosquitoes, giant ones. All right, so you look at a giant mosquito and you're like, man, this is not for me, but it's time for dinner. And you decide to go to your kitchen again. You go to your kitchen and then you get your dinner and you're like, you know what? I want to take one more road trip before I go to bed. Where are we? I don't know. Where are we? Where are we going? Where are we going? Where are we going? Where are we going? Let's go to Jersey. Yeah, Jersey. All right, so we're in Jersey, and we're like, why did we end up in Jersey? No one knows. Let's go back home. Turnpike, pay all that money, and you go back home and you go back to your bed. All right, so this is your entire day. Okay, so in your entire day, you did all of that. Now, this is where things get crazy. Because your final position, initial position, is the same location, which is your bed, right? You end up in your bed. You're like, okay, time to go to bed for another adventure tomorrow. All right, so you go to bed, and right before you drift off into La La Land, that little voice in the back of your head, it kicks in, and it's saying, hey, today your displacement was 0. Today you got nowhere in life. And with that thought, your eyes get wide open and you can't sleep for the rest of the night. Because that's true, according to the displacement equation, because your final position, your initial position, is exactly the same. That day, you got nowhere. Isn't that cool? All right, tune in next time where we will go over speed and velocity. I'll see you later. Bye-bye.